Welcome to the Explainer. Look, today we're tackling a massive, massive headache for students, researchers, and really anyone who loves learning. If you have ever had to do a literature review, you know the exact drill I'm talking about. It's painful. You go to Google Scholar or IEEE Explore, you type in a topic, click a link, check if it's open access, hunt for that tiny download button, manually save the PDF, and then you go all the way back and do it again for dozens of papers. It is absolutely exhausting. But what if we could build a custom robot to just do all of that for us? You know the old way. It's tedious, it's totally manual, and it eats up literally hours of your time. But the Python way? Imagine just running a simple script, typing in machine learning, pressing enter, and then walking away to grab a coffee. While you're gone, the script automatically fetches 10, 50, or even 100 open access research papers and just neatly organizes them right into a folder on your computer. Today, we're going to break down exactly how this automation magic actually happens, step by step, even if you are a complete beginner to programming. Here is our agenda. 1. Gathering blueprint inputs. 2. Searching with the OpenAlex API. 3. Finding PDFs using DOIs. And 4. Downloading and saving safely. Let's dive into Section 1. Gathering blueprint inputs. Asking the user. Okay, so in Python, we use this super basic command called an input function to ask the user 4 really specific questions. First up, what's the topic? Let's say machine learning. Second, what's the limit? Like how many papers do you actually want? We'll say 10. And then third and fourth, what is the exact date range? Maybe we only want papers from the year 2023 to 2025. By answering these simple prompts, we establish the absolute boundaries for our search. It's kind of like handing a highly specific shopping list to our robot right before we send it to the store. Moving right along to Section 2, Searching with OpenAlex API, the digital librarian. Now here's a really crucial question, especially if you're new to programming. How does our tiny little local Python script sitting on your laptop actually talk to a massive global database containing millions and millions of research papers? I mean, we obviously can't download the entire database to our computer just to search through it, right? So how do we bridge that gap? Well, the answer is an API, which stands for Application Programming Interface. Now, please don't let the technical acronym intimidate you. Think of an API exactly like a librarian. You know, you don't wander the millions of bookshelves yourself. You just hand your very specific request to the librarian, and they run off and bring you exactly what you asked for. In our script, we use a completely free public API called OpenAlex. We send OpenAlex our topic, our date range, and crucially, we apply a filter specifically asking only for open access papers. OpenAlex does all the heavy lifting on their massive servers and just hands us back a neat little list of matching research papers. And the best part? They never even ask us to keep our voices down. All right, Section 3, Finding PDFs using DOIs, the locator. So to actually find the PDF files, we really need to understand a vital concept, the DOI, or Digital Object Identifier. Every single published research paper gets one of these. It's just a unique string of letters and numbers. You can basically think of it as a social security number or maybe a permanent barcode for a document. Even if a research paper completely moves to a different website, its DOI remains exactly the same. So when OpenAlex gives us our initial search results, it thankfully includes the DOI for every single paper. And here is exactly how we use that barcode. We take the DOI from our very first search and we hand it right over to a second API. This one is called Unpaywall. Unpaywall's entire job in life is to find free, legal, open-source versions of research papers. So our script sends them the DOI along with an email address. That email is really just a polite little wave to their server so they know we aren't some malicious spammy bot. And in return, Unpaywall replies with the exact direct web link to the PDF file. Bam! Now we finally have the target right in our sights.
And that brings us to Section 4, Downloading and saving safely, the delivery.
So web servers can actually be a little paranoid. If they suddenly see a faceless Python script aggressively trying to download PDFs, they might panic and slam the door shut, thinking it's some sort of cyber attack. To get around this, our script puts on a disguise. It sends a user agent header that says Mozilla/5.0. By sending this specific little phrase, our script is basically waving a friendly flag that says, "Hey there, I'm not a scary automated bot, I'm just a normal human using a regular web browser." This simple disguise ensures the server actually accepts our download request. But hey, putting on a disguise just isn't enough. We also have to behave nicely, right? If we fire off 100 requests in a single second, the API will absolutely block our IP address.
To prevent this, the script intentionally goes to sleep for 2 seconds between every single API search. As a beginner, it's absolutely vital to learn this concept. It's called rate limiting. By adding a simple 2-second pause, we respect the server's rules and ensure our script can just run smoothly without getting banned.
And, because downloading an actual PDF takes way more bandwidth than a simple text search, our script has to become even more polite. After successfully downloading a single PDF, it pauses for a full 10 seconds before starting the next one. It's like a built-in speed limit. Yes, it definitely makes the total runtime a little longer, but honestly, it is the difference between an automation that works flawlessly and one that just violently crashes after 3 downloads. Okay, so once the download finally comes through, organization is key. The Python script doesn't just blindly dump a massive pile of randomly numbered files onto your desktop. Oh no. First, it automatically creates a dedicated folder named after your exact topic, like machine learning. Then, it double-checks to make absolutely sure the file it grabbed is actually a PDF and not some broken web page. Finally, it cleanly names the file, starting with the publication year, followed by the paper's title. So you get this beautifully organized, chronological library without lifting a single finger. And while the script is taking its little 2-second and 10-second coffee breaks, you aren't just staring at a blank screen wondering if the whole thing crashed. The programmer actually built in live status updates using emojis. If a paper is successfully downloaded, it prints the title with a satisfying green checkmark. If a paper fails to download, it gets a red cross emoji. The script uses this neat little safety net called a try-except block. That means instead of crashing the entire program when it hits a snag, it simply skips the bad link and happily moves right on to the next one. It's clean, it's informative, and honestly, it's super satisfying to watch. So, let's do a quick recap of this beautiful little assembly line we've just unpacked. Step 1, we ask the user what they want. Step 2, we query the OpenAlex API to find matching open access papers. Step 3, we use that unique DOI barcode to find the exact PDF link via the Unpaywall API. And step 4, we use a clever browser disguise and polite pauses to download and neatly file away all those PDFs. It really is just a perfect logical assembly line.
Learning basic programming concepts really isn't just about writing code. It's about building personalized robots to buy back your own time. A task that used to take hours of mind-numbing clicking now takes a single command and the time it takes to sip a cup of coffee. So I'll leave you with this. Now that you have seen just how accessible Python automation can be, what tedious digital chore in your life are you going to automate next?